Well, hello there, it's Keith here, and this is lesson 32 of the platform-specific series of my 68000 assembly programming tutorials, and my run on the Sharp x68000 is continuing because it's got so many amazing graphics functions that I think we need to take a look at. And today we're looking at what's known as the text layer. I say text layer in quotes because it's kind of a bitmap layer. It's just a bitmap layer in a slightly different format. So we're going to be taking a look at it. The text layer is a 16 color layer. It's potentially 1024 by 1024 because I say potentially because it won't all fit on the screen in our 256 by 256 screen mode today. But the interesting thing about it is the memory format is completely different. Usually our 16 colors are defined by a single nibble, and the 4 bits that make up a 16 color value will be all in that nibble. But the text screen doesn't work like that. It's split into bit planes, very much like the Amiga. So basically all of the bit zeros of our entire screen are in one block of memory. All the bit ones, all the bit twos, and all the bit threes are in these 4 separate blocks that are consecutive within VRAM. What this means is that it's not going to be really very realistic to convert our previous bitmap into the correct format for the text screen. But fear not, we can export the correct format with Sprite Editor. I actually use the same Amiga format that I'd used before, so the benefit of covering so many tutorials these days, I don't actually need to write new functions most of the time, because most of the time Sprite Editor can already export in basically the same format as the new systems need. So anyway, we're going to be using the Amiga style format. We're going to be converting it for screen VRAM. We're going to learn about that text screen. Let's go over to today's example and let's take a look at what we've got. Okay, so this is the example, and I've actually disabled some of the code to start with because I want to make a point about the text screen, which really surprised me when it ran. So here is our example. If we just fast forward here. Now you can see there going down the screen is ProgX, and then there's a Z, and then there's a flashing cursor. This is the operating system still running in the background and still animating the text screen, which I really didn't expect, but that's what it's doing. And you also maybe saw there, go past the function key display. These will be being displayed on our higher resolution screen at the bottom, and at the top the ProgX would be at the top and the function keys would be at the bottom. So they're still running. Bit of a surprise there, but we're going to have to deal with them. So yeah, okay, so the Z is actually being shown by this routine itself, just to make it clear that the operating system is still operating that screen in the background. There's the command, and I noticed there's a missing command there. There's the command that's actually showing the Z. This is actually just as a test to show that it's really still running. Now what we're going to do is we're going to turn all that junk off. We're going to turn the cursor off. We're going to use function ff23. That's a DOS function. It's one of these ff line commands, as they're called. So we're going to use that, and we're going to use function 12, which will turn the cursor off. We're then going to use function 0a, which is a clear screen routine, but we need to specify a 2 there to tell it to clear the whole screen. That's going to clear the screen. And then we want to turn the function keys off from the bottom, and we use function 0e, subfunction 3 here, to disable those function keys. And now if we run again, all of that junk's going to be gone, and we're going to have proper control. Here we go. So now we've got none of that garbage floating around. Now you'll see there's lots of different layers here. This is the sprite layer. These are the bitmap layers, these bright chibicos, and this dark chibico here that's going down the screen, that's the text layer. Now it's not dark because of any limitation of the text screen. That's just merely the palette I've selected just to make it clear which one we're looking at in today's example. Now the palette for the text layer is actually sprite palette 0, so we're defining that here, and these are darker versions of the normal chibico palette. The other thing that we need to do though is we need to turn the text layer on, so we do that with E82600. It's this bit here, I believe, and we also need to give it an appropriate layer, so we need to select the layering of the text layer compared to our other graphics layers, so we're doing that as well there. So that's set up our screen, and we now can use it. Now, as I say, the x68000 text layer is in completely a different format to the bitmap layers. So we're showing a bitmap to the screen in very much the way we did with our chibicos, but we're using different functions, not just for calculating the memory address, because we used a different memory address calculation before, but before we could always use the same bitmap drawing routine, and now we cannot, because the bytes of the chibico bitmap need to be written to 4 different areas of the memory for the 4 different bit planes. Well, let's have a discussion about the starting calculation of the screen memory. So here is our starting calculation here. The base of the text VRAM, I'm using the term text here because that's what they call it. It's actually a 16 color bitmap, is at AE and 5 zeros here. And that's the start of bitplane 0. Now, the bitplane 1 will be at E2 and then 4 zeros. Bitplane 2 will be at E4 and then 4 zeros. And bitplane 3 will be at E6 and then 4 zeros. So we're going to need all those different addresses, but this function is just calculating the first one. We are calculating the X and Y offset. Now, each byte within the bit plane will contain a total of 8 pixels. So we're basically dividing our X coordinate by 8 to get the byte position that we want to draw to, and then we are multiplying the Y position by 128 because there's 128 bytes per line within that video memory. So that's what we have to do. Now, this function will return the screen base for our drawing in register A3, but then what we're going to need to do is we're going to need to calculate the relative offsets to the other bit planes. We couldn't use an offset here because that's outside of the range of valid values for this processor, so we are loading them as an addition to registers A4, A5 and A6 based on the base in A3 here. So here we've calculated our other bit plane addresses. Now, Acrus Byte Editor exports the Chibico bitmap. Basically, each cluster of 8 pixels, it outputs the first byte is bitplane 0, the second byte is bitplane 1, the third byte is bitplane 2, and the fourth byte is bitplane 3, and then it continues back to bitplane 0 for the next 8 pixels. So what we're needing to do is we're needing to read in 1 byte at a time from our source bitmap and write them to the 4 consecutive bit planes here. So we do that for a full line, and then we move down a line by adding 128 to the line addresses here. Now, I should point out, this is probably not the most efficient way of doing things. I think it would be more efficient if you had all of bitplane 0 for the Chibico bitmap and then just dump that to the screen and then move to bitplane 1 and did all of the bitplane 1 bits for the Chibico bitmap and then 2 and 3 respectively. The reason I'm doing it in this format is because this is the same format as I use for the Amiga and the Atari ST. I'm kind of molding my code to match my outputted file. Now, as I say, it's not the most efficient, but it's more than enough for this, and it's honestly more than enough for any program I'm ever likely to write on this system. So just say it's not the best, but it's good enough, and that's sufficient for today at least. Anyway, so that's how we're calculating our memory address, and that's how we're transferring our Chibico bitmap to the screen. The final thing we're doing is we're scrolling, and the scrolling routines are exactly the same as our other ones. We just use different memory addresses again. E8 to 0014 is the X scroll, E8 0016 is the Y scroll. Before we were only scrolling the Y scroll, but we can scroll the X scroll if we prefer. There it is. So we can scroll this as we see fit. You know, it's got full control. And as I say, it's basically another bitmap layer, just in a slightly different format. I've been racking my head, and the only reason I can assume they're using a different format is, I guess, if you just wanted to do 2 colors, then you don't have to write as much data to change the screen if you are splitting bit planes like this. But it's a bit of a surprise when the other layers are so powerful, and when the text layer itself is so powerful as well. I mean, it is effectively a 5th bitmap layer. It's just slightly odd that it's not using the same format as the other 4. But as I say, it's very nice. Anyway, that's all we're going to be covering today. Next time, we're going to be coming back to the x68000, and we're going to be looking at the screen modes, the other screen modes, because it can do higher resolutions and higher color depths. So we're going to be having a play with them as well. I just need to finally mention my book, because I've written a book. It's called Learn Multi-Platform Assembly Programming with Chibi Akumas. It's a beginner's introduction to Z80, 6502, 68000, 8086 and ARM. So a lot covered there. It's only a little book, so it covers it quickly, but I try to cover things in the simplest way possible because it's aimed at beginners and idiots like me. So the first chapter of the book is an introduction. It discusses terminology, common concepts that you might not be familiar with, things like VBlank, things like VDPs, and what RAM and ROM is if you don't know the difference. Maybe most of you do, but as I say, it's designed for absolute beginners, and it's hopefully something that everyone can benefit from in some way. After the introduction chapter, we go into the individual processors, discussing registers, common concepts that you might need to know about, segments, things like that. And there's then some examples on an easy system system. So 8086, it covers DOS. On Z80, it covers the CPC. 68000, it covers the Mega Drive Genesis. And there's a few examples on how to get started on that system. Basically, the simple series that I've covered before. And then finally, for each processor, there's a full instruction set of the essential commands. So all the commands you're going to need to get started, the flags that they use, and hopefully I've described them in a way that's going to be easier for a beginner, because I went back to the sort of manufacturer's manuals to check my documentation was correct, and sometimes it was explained in a way that I didn't really feel was appropriate for normal people who don't write processor manuals for their day job. So I've tried to give easy ways of describing how the commands work that maybe will be easier for you to understand. Anyway, if you want to support the channel, or if you just want the book, then you can go to Amazon and you can buy it as a print copy or as a digital Kindle book. Hopefully by the time you're watching this video it will be out, so please take a look in the description below and you should be able to find a link for that. Anyway, I hope you've enjoyed this today. Thanks for watching.